another catchy mathematic rhyme like go students, go students, go students.
Hello and welcome to the Kearney Math Show. Thank you all for tuning in today. On today's episode, we are going to be featuring entry number 7, in which we are reviewing angles and triangles. So before we get started, go ahead and write entry number 7 at the top of your bowling review sheet. So we're going to just review some things about angles, and then we're going to review some things about triangles. So specifically, let's talk about angles. Complementary. When you hear the word complementary, what do you hear? Complement. So complementary angles are two angles that add up to 90 degrees. So complement, meaning complementing the saying something nice is the right thing to do. So two angles that add to 90 degrees. Okay, so anytime you see the word complementary, you're going to take those two angles, add them up, and set them equal to 90. Supplementary angles. Two angles that add up to 180 degrees. So what do complementary angles look like? If they add up to 90, what does a 90-degree angle look like? Looks like a right angle. So we're going to draw, if we have complementary angles, we'd have a right angle, and it would be broken into two parts. So let's say this is 2x. Let's say this is 50. So we have 2x plus 50 equals 90, and we can solve for x. Whereas supplementary, the picture would actually 180 degrees would be a straight line. So if you have, this is 5x and this is 45, we have 5x plus 45 equals 180. Okay? Vertical angles. Remember, vertical angles, when you see the word vertical, you're thinking of the V, the vertex. Vertical angles are angles that their vertices are touching and they are congruent. Okay? So vertices touching, they're across from each other. And the main thing is they are congruent. And remember, congruent is just a fancy word for equal. So two angles that are equal. So an example picture, if we had this angle and then we cut it through with another angle, let's let this be 38 and this be 2x. Since their vertices are touching, those 2 points, and they're across from each other, we know they're congruent. So if one side is 38, that means the other side is 38. So then you can solve for x. So anytime you have two angles that are directly across from each other, set them equal to each other. They are congruent. Okay? And adjacent. Miss Wilkinson's room is adjacent to mine. Miss Mabry's room is adjacent to mine. That means that if you have two angles that are adjacent, they are beside each other. Okay, so just to recap, if you see the word complementary, you're always looking, if complementary, that means two angles make a right angle, add them up to 90. Anytime you see a straight line that's been broken down into different angles, then the two angles that add up to 180 is supplementary. Vertical, they're across from each other and they are congruent. Always look for those vertical and supplementary angles to help you solve problems. Okay, so now moving on to triangles. Let's list the different types of triangles, and then we'll talk about some specific things about triangles. So remember the word equilateral. When you hear the word equilateral, what do you hear? Equal. So equilateral means all angles and all sides are congruent. All angles and all sides are equal. scaling, or let's do isosceles next. So when you hear isosceles eyes, think about how many eyes you have. Isosceles means two. Two angles and two sides are congruent. And then the last one, we have equilateral, all equal, scaling, isosceles eyes, two, scaling, no sides are equal and no angles are congruent. So no sides and angles are congruent. So look for those keywords. If you see a keyword when you're taking your test or tonight when you're working on your practice, underline that keyword and write what it means. Mark the text. So if you see the keyword complementary, mark that text and write adds up to 90. If you see the keyword scaling, mark the text, write no angles, no sides are the same. That will help you with breaking down these problems. Okay. Next, how many degrees are in every triangle? So if you remember when you were forming, we took triangles and we cut off the corners and we put them together. Those corners made a straight line. So we learned that all angles in a triangle add up to 180 degrees. All angles in a triangle add up to 180. So you can always, if you're given two of them, you can find the missing one. Okay. And then our last thing, do you remember when we worked with straws and I gave you some straws, different lengths, and I said, take these straws and try to make a triangle, or take these straws and see what doesn't make a triangle. What do we find? If you had one piece of the triangle that was too long and the other two were too short, you remember they couldn't touch, they couldn't make that triangle. So in order for three sides to make a triangle, the two smaller sides have to actually be bigger than that longer side so they're able to touch. They cannot be equal. They must be bigger. So the two smaller sides must add to be bigger, not equal, but bigger than the longer side. For instance, if you had 4, 10, and 6, and we want to know if that made a triangle, we add up our two smaller sides. So 4 and 6. 4 plus 6 equals 10, so it's not bigger, so they would not be able to touch, so this would not make a triangle. Okay, let's think of a different one. If I had 5, 7, and 4. If I added my two smaller ones, 5 and 4, that would be 9. So it's bigger than 7, so that would make a triangle. And since all three sides are different, what kind of triangle would it be? What do we call when all three sides are different? Scaling. Okay? So I'm going to do a practice problem with you, and then I'm going to let you work on your own. Okay? So let's look at the very first one you have there. If you look, we have, it says SU, basically this line right here, SU, intersects at point R, and we know that this one is 3x minus 15, this angle, and this one is 75. Now, if you look at the top, what do you call two angles that are directly across from each other? Vertices are touching. Vertical. What do we know about vertical angles? They are congruent. So if one side, this top one is 75, what do we know about the bottom one? It is also 75. So that means we can say 3x minus 15 has to equal 75. So now we can solve for what x would be. So draw your line. What do you want to get rid of first? The constant. So what do we do to get rid of minus 15? We would add 15 to both sides. So whatever you do to one side, you do to the other. Bring down your 3x equals 75 plus 15. is 90. And then what is happening with the 3 and the x? They're being multiplied, so I would do the opposite, which is to divide. 3 divided by 3 is 1. 1 times x is x. 90 divided by 3 is 30. How can I check to make sure that is correct? I can always plug it back in for my x. So we put in 3 times 30 is 90. 90 minus 15 is 75, so it works. Okay? So as you're working through these, remember, complementary add up to 90. Supplementary add up to 180. Vertical are across from each other and they're equal. All angles in a triangle add up to 180. The 2 smaller sides must be bigger than the longer side. And just know those different angle triangle names: isosceles, scalene, and equilateral. And I'll be calling you over to work. So when you're solving these problems on the back and on the front, if you don't know how to set it up, look back at the front and see if one of those things at the top will jog your memory and help you know how to set it up. Okay? Good luck, guys. Make me proud. Peace out, Rainbow Trout. Love you, mean it.